So in this video we are going to see the series of steps through which K2Cr2O7, that is potassium dichromate, is synthesized.
Potassium dichromate K2Cr2O7. It is a very strong oxidizing agent.
Because the oxidant state of chromium in this compound is +6.
Correct. So and it is obtained from chromite ore. Ore is FeCr2O4, which is FeO.Cr2O3.
Okay.
And now first step for preparing it is concentration of chromite ore. And after concentrating it, step 2 is conversion of concentrated chromite ore into Na2Cr04 by roasting. And concentrated chromite ore is fused with molten Na2CO3 in the presence of air, with Na2Cr04 and Fe2O3 are formed.
Also the color of Na2Cr4 is
yellow. Okay. Now step 3 is conversion of Na2Cr04 into Na2Cr07. Aqueous solution of Na2Cr04 is acidified to obtain Na2Cr02O7, and the reaction is this, and its color is orange.
Okay.
Now the filtered and acidified, and now it is filtered and acidified with H2SO4. A hot solution of Na2Cr2O7 is obtained, which is reacted with KCl to convert sodium into potassium, to replace sodium into potassium, which has orange crystals.
Okay, so in this reaction potassium replaces sodium.
Yes. Now because sodium dichromate is more soluble than potassium dichromate. Now for conversion of Cr04 2- to Cr2O7, we can acidify it, and for conversion of Cr2O7 2- to Cr04, we can add a basic substance in it.
Okay, so Cr04 2- in acidic solution becomes Cr2O7 2-, and which when treated with basic solution gives us back Cr04 2-.
And there is a very important reaction. This is an acidic solution in which chromate ion is converted into Cr3+ ion.
Okay. So we need to remember all these formulas and reactions.
Especially this, in which it is acidified.
Okay. So now that we have seen the preparation of K2Cr2O7, we are going to see the series of reaction involved in the preparation of KMnO4, that is potassium permanganate.
Potassium permanganate is a strong oxidizing agent, and it is a salt of permanganic acid HMnO4, which is unstable acid and exists only in solutions.
And can you draw its structure?
Yes. KO MnO O. Okay. And it is prepared by the fusion of MnO2 and with the alkali metal hydroxide and an oxidizing agent like KNO3.
And what's MnO2 called?
MnO2 is pyrrolysite. Pyrrolysite is the ore of it, and it is prepared in large scale by this method.
Okay.
And K2MnO4 is dark green in color. Okay. Now let's go to the next reaction. In this reaction, K2MnO4 is fused, and obtained the above reaction is extracted with water, and the solution, after filtrated, is converted into potassium permanganate KMnO4.
Okay, so a disproportionation reaction is occurring here.
Yeah, and this KMnO4 is purple in color, and the reaction is same in neutral and acidic medium.
Okay.
Okay.
So this is how KMnO4 is prepared.
Yes.
Okay, so let's now solve this question in which we have to find the magnetic moment of Mn in the compound MnO4 minus.
Okay, so to calculate the charge of Mn in MnO4 minus, we take the charge of Mn is equals to X.
Okay.
So X, and the charge of oxygen is always minus 2. Therefore, X plus minus 2 multiplied by 4, which
as
is
there
the
are
amount
4 oxygens.
of 4 oxygen, is equals to charge on the whole compound, which is equals to minus 1.
Okay.
Therefore, X is equals to 4 into 2 is 8, minus 8, which is equals to plus 7. So the charge is plus 7 of Mn.
Okay, so the oxidation state we have found out is plus 7.
And Mn has a configuration of S2 and D5.
Yes.
Therefore, as the charge is plus 7, all the electrons in both the cells will disappear, and the subshell will look like this and will be empty.
So both S and D subshell will be empty.
And the formula for magnetic moment is under root of n into n plus 2.
And since n is 0, so magnetic moment will be 0 Bohr magneta.
Yes, exactly. So the answer is A, 0.
So in this question we have to just find out the electronical configuration and then the oxidation state, and then we have to draw the orbital diagram, and in this case n, which is the number of unpaired electron, is coming out to be 0. So magnetic moment is root of 0 plus 0 into 0 plus 2, that is 0 Bohr magneta. Okay, so in this question we are going to discuss the magnetical properties of chromium, Mn2 plus and Fe2 plus ions.
Okay, so first we will take chromium. Chromium has an atomic number of 24. So by the trick, this its subshell number of electron in its subshell is D subshell is 4 and S2.
Most of the students do this mistake.
Yeah.
But it has an exceptional electronic configuration.
Exactly. So one of the electron goes from S to D. So it becomes S1 D5. So the unpaired number is 6 C. S has 1 and D has 5. 1, 2, 3, 4, 5. So
n is equal to 6.
Yes. So mu is equals to under root of 6 multiplied by 6 plus 2.
That is under root of 48.
Is equals to under root 48. Correct. Now we will calculate the magnetic moment of Mn2 plus.
Okay.
Mn2 plus has atomic number of
25.
25. So Mn has atomic number of 25. So electrons in its subshells will be S2 and D5. But
Yes.
Mn2 plus will become S0 D5. Therefore,
They are, so n is equal to 5.
so S will be, and there will be no electron in S, and there will be 5 electron in its D.
So the number of unpaired electrons are 5 in this case.
So n is equals to 5, and mu will become, mu is equals to under root of 5 into 5 plus 2.
That is under root 37.
Yes. 35.
Okay.
Now we will calculate magnetic moment of Fe2 plus. Fe2 plus, the atomic number of Fe is 26,
Yes.
and the number of electron in its D subshells are S2 T6. Okay.
Okay.
After removing 2 electrons, we will get S0 T6. So the D subshell will look like this. 1, 2, 3, 4, 5 and 6.
So there are
So
4
one will
unpaired
pair.
electrons.
Yes, so there will be 4 unpaired electron, means n is equals to 4. So mu will become, mu is equals to under root of 4 multiplied by 4 plus 2, which is 6. That is equals to under root of 24.
Okay. So in this question you have to first, to solve such kind of question, you should remember their atomic number of the compounds. Okay, and you have to calculate, find out the electronic configuration, draw their orbital diagrams, find the number of unpaired electrons, and just apply the formula to get their magnetical moment. Okay, let's find out which of the following given ion is diamagnetic.
So now first ion is CO plus 2. We all know that the atomic number of CO plus 2 is 27.
Okay,
So its electronic configuration will be
S2D7.
S2D7. So so after removing 2 electrons, this will become S0D7.
Okay,
So its d subshell will look like this: 1, 2, 3, 4, 5, 6, 7. So there will be 3 unpaired electron, and it's equals to 3. So it will not be an diamagnetic ion, as there are unpaired electron, which means there will be some magnetic moment. But
so you mean that it's paramagnetic?
yeah, as diamagnetic means there should be zero magnetic moment. Now coming to the second B part, CO plus 2 has an atomic number of 29. Therefore its electronic configuration will become this is an exception. So its electronic configuration is
S1D10.
After removing 2 electrons, this will become S0D9.
Okay,
So
let's draw its orbital diagram.
which is 1, 2, 3, 4, 5, 6, 7, 8, 9.
So it has got one unpaired electron.
So N is equals to 1, and this is also not an diamagnetic ion. This is an paramagnetic ion. Drawing for Mn2 plus has an atomic number of 25.
Okay,
So its electronic configuration is S2D5. So its d orbital will be like this: 1, 2, 3, 4, 5.
but after the removal of 2 electron, its electronic configuration will be S0D5.
Exactly. Thanks, my friend. Therefore, N is equals to 5, and this is also an paramagnetic ion. This is not a diamagnetic ion. So, coming to the next part, Sc3 plus. Sc3 plus has an atomic number of 21. Therefore, its electronic configuration will become S2D1. After removing 3 ions, as its
3 electrons. Okay,
as it has charge plus 3, therefore S0D0. So there will be no electrons in its d subshell or s subshell.
so its valence shell will be empty.
So N is equals to 0, as there is no electron, no unpaired electron.
So it's diamagnetic.
Yes, so it is diamagnetic. So answer is Sc3 plus.
Okay, so in this type of question, we have to just find the electronical configuration and find out the number of unpaired electrons. Okay, so in this question, you have to find which of the following given species will impart color to an aqueous solution.
So A is Cu plus 2. Cu plus 2 has an atomic number of 29.
And its configuration is S1D10.
Exactly. So its d subshell, after removing 2 electrons, this will become S0D9.
Okay.
So its d subshell will look like this: 1, 2, 3, 4, 5, 6, 7, 8, and 9. So unpaired electron will be there, and N is equals to 1. So
it will be a paramagnetic species and it will impart color to the solution.
Perfectly. Second is Zn2 plus. Zn2 plus has an atomic number of 30. So its electronic configuration is S2D10. After removing 2 electrons, this will become S0D10. So this will become 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there is no so this is a diamagnetic.
So no D transition is possible. As a result, it will not impart any color to the solution.
Yes. So Now coming to the third, Cr3 plus. Cr is an has an atomic number of 24 and its electronic configuration is S1d5. After removing 3 electrons, this will become S0d3. So this will become,
so 3 unpaired electron will be there.
1, 2, 3, n is equals to 3.
So DD transition will take place and its solution will be colorful.
Yes. So now Ti4 plus. Ti4 plus will have Ti has an atomic number of 22. So its configuration is S2d2. After removing 4 electrons, this will become S0d0. So this has no electrons, no d electrons. So this has an n is equals to 0 and it will not impart color to its aqueous solution.
So to find out that if aqueous solution of an ion is colorless or it imparts color, we have to just find the electronic configuration, and using that we have to find just the unpaired number of electrons. If the d orbital is full or if it's empty, then the solution will be colorless, otherwise it will be colored. Okay, so in this question we have to find that which of the following product is formed when K2CO2 reacts with H2SO4 in cold conditions.
ठीक है, तो A पार्ट है, A ऑप्शन है CrO3 और हम फर्स्ट हमें पता है कि K2Cr2O7 H2SO4 इन कोल्ड में रिएक्ट करता है तो Cr+3 बनाता है. रिएक्शन होती है goes to in acidic medium Cr+3. यहाँ पर चार्ज सबका निकालेंगे तो फिर A पार्ट का आएगा +6 एज ऑक्सीजन 3 है. इसमें निकालेंगे तो फिर आएगा +3 एज 2 × 3 6/2 +3. इसमें भी निकालेंगे तो भी आएगा +3. इसमें निकालेंगे तो फिर आएगा +6.
ओके,
तो फिर ऑप्शन हो सकते हैं ये या फिर ये, और हमको पता है कि इस रिएक्शन में SO4 भी आ रहा है तो आंसर होगा ये. वैसे भी हमें इस रिएक्शन को याद रखना है. नेक्स्ट एग्जांपल लेते हैं.
Because sulfate cation will be supplied by Kong H2SO4.
नेक्स्ट क्वेश्चन लेते हैं. इन डाइल्यूट अल्कलाइन सॉल्यूशन MnO4- चेंजेस टू
MnO2. As we already know.
ये भी चीज याद रखनी है.
In this question, we have to find that the given reaction, that is MnO4- plus electron that goes into MnO4 2-, we have to find the medium in which this reaction take place.
This reaction take place in a strong basic medium. So the answer is A.
Okay, let's move on to the next question.
In this question, cuprous ion is colorless.
We have to find the reason why cuprous ion is colorless while cupric ion is colored.
Okay, we know that cuprous ion is Cu plus while cupric ion is Cu+2, and we know that copper has an atomic number of 29. So इसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन हो जाएगा S1d10. आफ्टर रिमूविंग फर्स्ट क्यूप्रिक आयन के लिए सॉल्व करते हैं. क्यूप्रिक आयन के लिए +2 किया तो फिर इसमें हो जाएगा S0d9 कॉन्फ़िगरेशन. तो फिर इसमें एक अनपेयर्ड इलेक्ट्रॉन बच जाएगा. एज इसका d ऑर्बिटल बनाते हैं 1 2 3 4 5, 1 2 3 4, टोटल 9. तो अनपेयर्ड इलेक्ट्रॉन एक बच गया.
ओके,
अब क्यूप्रस आयन के लिए बनाते हैं. क्यूप्रस आयन के लिए इलेक्ट्रॉनिक कॉन्फ़िगरेशन हो जाएगा S0d10 क्योंकि इसमें से सिर्फ एक ही इलेक्ट्रॉन निकला है, एज सिर्फ +1 चार्ज है. तो इसका d ऑर्बिटल बनाते हैं. d ऑर्बिटल तो इसका पूरा का पूरा फिल्ड है, 10 के 10 इलेक्ट्रॉन है. तो फिर इसमें dd ट्रांजिशन नहीं हो पाएगा और इसका कलर्ड है. बिल्कुल सही, यही क्वेश्चन में दे रखा है.
इसका dd ट्रांजिशन नहीं हो पाएगा तो इसलिए कलरलेस होगा.
ठीक है, अब ऑप्शन पढ़ते हैं. बोथ हैव अनपेयर्ड इलेक्ट्रॉन इन d ऑर्बिटल. नहीं,
बिल्कुल गलत.
cuprous ion has a complete d orbital while cupric ion is incomplete d orbital. बिल्कुल सही, यही आंसर है.
Okay. So now, so by this we understand.